Hi everyone. Today we're going to talk about the application of optimization of two variables. One of the methods is least squares method. So this is one of the regression technique. So what is the method? You're given n points. This is y-axis, this is x-axis. You're given n points. So the idea is to find the best line or the closest line to each point given. So this is called the regression problem, and we're going to solve this problem using the least squares method. So the main idea is to find this function, linear function, ax plus b, where a is the slope of this function and b is the y-intercept. So here a and b unknowns. And we are given this input is set of endpoints, x1, y1, x2, y2, and xn, yn. And the output should be a and b. We should find a and b of this linear function. Okay, so how are we going to do this? So we're going to measure, how to think that this line is the closest line. We're going to measure this vertical distance to each point here, vertical distance, and we want this distance to be minimum. So the goal is minimize the sum of error. Okay, so first we need to come up with the objective function. So we need to write the sum of error in an appropriate way. So how are we going to do that? Error function is equal to, now here you can see that we will look at the distance between the point and the line. So here we can say that this is negative distance, here positive distance, here negative distance. So if you add them up, they will cancel each other. So to avoid this, we will keep the square of these distances. Find the error function as follows. Error is going to be the sum for each point. Now here xi, x1, x2, x3, etc. We have xn, x values. So for each x, we're going to look at the function's value at this xi minus actual y value, and we're going to take a square to avoid that canceling problem. Now, if you rewrite this epsilon, the error function is going to be i's from 1 up to n. F of xi is given by this axi plus b minus yi squared. So this is our objective function, which depends on, we can write it here that only a and b are known, so we can write it as a function of two variable a and b. So the aim here is to minimize this error function. So how are we going to minimize it? We're going to take a derivative of this error. So take a derivative of error with respect to a, and then equalize it to 0. And then similarly take the derivative of error with respect to b, equalize it to 0, and we will solve this system of linear equations. Okay, now let's take a derivative of this error with respect to a. So we know that derivative of sum is equal to sum of derivatives. So we can say that derivative of error with respect to a is going to be 2, by the chain rule 2 comes here, and axi plus b minus yi, and derivative of inside with respect to a. So when you take a derivative of this inside with respect to a, these values are going to be 0 because they don't contain a. So here only xi left. So this is going to be equal to 2a sigma xi squared plus 2b sigma xi minus 2 sigma xi yi. So we want this to be 0. And from the derivative of error with respect to b, we're going to obtain derivative of error with respect to b. We're going to obtain sigma 2 here xi plus b minus yi, and if you rewrite this, 0 is equal to 2a sigma xi plus 2b and 2bn minus 2 sigma yi. This should be 0. So we need to solve this system of equation. So if we rewrite it down, we're going to obtain a sigma xi square plus nb x bar minus sigma xi yi. This is equal to 0. And from the second equation, we're going to have a n x bar square plus nb x bar minus n x bar y bar is equal to 0. So if we solve this system of equations, so we're going to obtain a to be sigma xi yi minus n x bar y bar divided by sigma xi square minus n x bar square. And once we find a, b can be obtained as y bar minus a times x bar. So these two are the formula to find the unknown a, which is the slope of this line, and b, y-intercept of this line. Now let us look at this example. We are given 4 points, xy pairs, and now we need to find the best fit line for these 4 points. We can make a table here, put the x values, so -3, -1, 0, and 2, and y values 0, 1, 2, and 3. So in the formula, you can see sum of product of x and y values. So we can calculate it from this. So just multiply each row. -3 times 0 is 0. -1 times 1, -1. Here 0, and here 6. These are x multiplied by y. And we also need, in this formula, we need a square of x values. So when you take a square of x values, 9, 1, 0, and 4. And we can add this sum of x times y values. It is going to be this sum. And sum of the squares of x, it's going to be this sum. We also need this x bar and y bar. What is x bar? X bar is an average of x values. So it is simply sum of x values divided by number of x values. So sum of x values, if you add this row, if you add this column, -4 plus 2, it's -2 over 4 values we have. So it's -1 over 2. And similarly, y bar is sum of y values over number of y values. If you add the y values here, it's 6 over 4. So if you simplify, 3 over 2. Now we have x bar, we have y bar, and we know the sum of the xy, product of xy, and we know the sum of square of x. Now we can put into this formula. A is going to be sum of x times y, sum of this column, it's going to be 5. 5 minus n is 4 multiplied by x bar, -1 over 2, times y bar, 3 over 2, divided by sum of squares of x values, which is 14, minus 4 times n is 4 because we have 4 values, multiplied by square of the average of x. So it's -1 over 2 square. So if you calculate it, you can see that this is going to be 8 over 13. And similarly, we can calculate b. b is going to be average of y value 3 over 2 minus a times 8 over 13 multiplied by average of x values, -1 over 2. So if you calculate it, so you will obtain 47 over 26. So the function that fits these four points is going to be f of x is, remember, it's ax plus b. So it is 8 over 13x plus 47 over 26. This line is the best line for fitting these four values.